Three identical resistors, each of resistance 2 ohms, are connected to a cell of negligible internal resistance as shown. When switch is open, the power dissipated by R1 is 18 watts. What is the power dissipated by R1 when switch is closed? So when switch is open, there is no current through R3. Let potential difference provided by a cell be V, and we can see that there are two resistors, each of resistance 2 ohms, in series, and we know that components in series divide total potential difference across them proportionally to their resistances. It means that R1 and R2 divide this V in the ratio 2 to 2 or 1 to 1, so potential difference of voltage across R1 is V over 2, and the potential difference across R2 is also V over 2. It's the same as to find the total resistance in series, so add up 2 plus 2 is 4, then current in this circuit through R1 and R2 is V over 4, then potential difference across R1 is current V over 4 times resistance, it's 2, so we get the same result. Then what is power? Power is potential difference squared divided by resistance, so power dissipated by R1 is V over 2 squared, so V squared over 4 divided by 2, it's V squared over 8, and it is given that it's 18, so we can conclude that V squared is 8 times 18. And let's get a similar expression when switch is closed. When switch is closed, there is current through R3, and there are two components, R1 and R3, in parallel. But we can consider R1 and R3 as one component with resistance which is equal to the total resistance, and since they are in parallel, we can apply a formula that 1 over R total is equal to 1 over 2 plus 1 over 2, or when resistances are equal, the total resistance is equal to resistance of 1 divided by number of resistors, so it's just 2 divided by 2, it's 1. So we can consider R1 and R3 as one component over resistance 1 ohm, and R2 over resistance 2 ohms, and potential difference provided by a cell the same V. And now two components in series divide V in the ratio 1 to 2, so potential difference across these 2 points is 1/3 of V, and across R2 is 2/3 of V. We know that in parallel potential difference is the same, so potential difference across R1 is V over 3, and power becomes potential difference squared, V over 3 squared, divided by 2. Not 1, but 2, because we consider R1. And using this result, so substituting 8 times 18 for V squared, we get that it is equal to, we can simplify, it is equal to 8 watts, so A is correct. The next, three identical resistors of 6 ohms are arranged as shown. What is the resistance between X and Y? So the total resistance is required. It looks a bit confusing. It's not clear whether they are in parallel or in series, but we can see that there are empty wires, and we can remove them by connecting this point together with this tail to this point, as well this point together with this tail to this point. So it becomes this and this becomes here and X here. So this resistor becomes here and point Y becomes here, and now it's clear that they are in parallel, and applying the formula that 1 over R total is 1 over 6 plus 1 over 6 plus 1 over 6, or since resistances are equal, the total resistance is equal to resistance of 1/6 divided by number of resistors, so it's 2. Or here we can see that we get the same result. So A is correct, and that's all for this question.